Good afternoon, everyone. Welcome to the 11th class of reagents in organic synthesis. In this class, I am going to discuss about silver-based reagents, platinum-based reagents, rhodium-based reagents, and nickel-based reagents. First, I am going to discuss about silver-based reagents. We all know that silver and gold are pi-acceptor reagents, so it mostly activates the pi bond. So first, I am going to discuss about the activation of pi bond by silver. So in the previous class, I have already discussed about the gold-based activation of the pi bond. So if we have a pi bond such as alkyl, this is a pi bond, pi electron are there. So if there is say this is the terminal alkyl, this terminal alkyl, and this is the substituted alkyl. So in both the cases, silver activate the pi bond. So if the the substituted alkyne are there. So in presence of silver, first is coordinate. So this is the coordination happen to the pi bond and form this kind of uh, silver added product. So this kind of electrophilic product will be formed. If the alkyne is terminal, so first it's activate like this way, and after that reaction, so it will form this terminal silver attack product. So now if there was a nucleophile, so the nucleophile can attack two ways. Either a nucleophile attack this way, or if it is terminal alkyne, it should be happen from the silver side. Or if it is the substituted alkyne, then there are the two possibilities, this side and the other side. So first I am going to discuss about the CO2 fixation reaction by terminal alkyne in presence of silver iodide and carbon dioxide. So what happens is there, any terminal alkyne first react coordinate with the silver, and after that CO2 fixation happen. So this will form like this way, silver. So now this is partially positive charge, this is partially negative charge. Now in presence of CO2, this will react and form this negative charge. Now under acidic work of proton source, it will form the acid. So this is the mechanism actually. Uh, First in presence of silver iodide and cesium carbonate from this coordinated compound, so which activate the phenyl acetylene. This is phenyl acetylene, phenyl acetylene. So from this terminal activated silver product, after that CO2 in presence of CO2. So this is the positive, partially positive. This is partially negative. So it will act on the carbon dioxide and from this and further protonation giving the acid. So further protonation giving acid. So this is the reaction of the alkyne onto carbon electrophile. This is carbon electrophile file. Now nitrogen can also react on the alkyne through silver or gold. In the previous class, I discussed about the gold catalysis. So now I'm going to discuss about the silver catalysis. So just like gold, the carbon also activated by the silver like this way. And there is a two possibility. Either this can react on this side via 6 endo decyclization, or it can react this side via 1, 2, 3, 4, 4x, 4x. So this is the mechanism. So first alkyne activation by the silver, and after that 5 endo decyclization. So this amine react with this center via 5 endo decyclization, and after that proto D metallation happens. So this silver is partially positive, this is partially negative. So now in presence of proton source, this is proto D metallation happen and giving this indole ring. So this is indole. two substituted indole, from these silver base reagents. So this is the nitrogen nucleophile I am discussed. Now I am going to discuss about the 4 plus 2 cycloaddition reaction in presence of silver. So just like that previous silver was activate the alkyne via this way, then this is the 5-hexo-decyclization. 5-hexo-decyclization happen, giving this product. Now this is the fourth, this pi bond behaving like a 4 pi electron, and now this will react onto the carbocation. So after the reaction, it will form carbocation here, and now this pi bond is form carbocation, and after the deprotonation, minus H plus will get this product. This is the 4 plus 2 type of cycloaddition. So if we see like this way, so it like tosyl, CO, this. So this is the 4 plus 2 type of cycle. This is the 4 plus 2 type of cycloaddition. So 6-member ring is following. Now I'm going to discuss about rhodium-based reagents. So the industrial application of rhodium-based reagent is the Monsanto process. So in these cases, what happened is this case acetic acid formed by methanol. So from methanol to acetic acid formation in catalytic fashion under rhodium is the Monsanto process. So what happened in this is the active catalysis species. So RH rhodium dicarbonyl diiodide. This in the presence of methyl iodide from this hexacoordinated uh, oxidative added methyl iodide oxidative added production product oxidative addition happen. So from this hexacoordinated compound, now then what happened? The insertion happens. So this COCH3 insert onto the carbonyl center. Insertion happens. So giving this COCH3 attack product. In next what happens? One molecule of carbon monoxide react with the pentacoordinated compound and form this hexacoordinated back compound. After that, what happens? Reductive elimination of this CH3CO and iodide from this acetyl iodide. Now this acetyl iodide react and generate this acetic acid. So this is the process. So methanol after liberation of HI from this acetic acid, and this liberated HI with the methanol from methyl iodide. So this is the catalytic cycle. So what the active species is the acetyl iodide. Acetyl iodide in presence of water from HI and acetic acid. That HI hydrogen iodide react with the methanol and from methyl iodide. So this is the first is the catalytic species anion cis rhodium carbonyl iodide. The first organometallation of methyl iodide to rhodium cis plus methyl iodide addition then form the hexacoordinated species. Then migration and methyl group adjacent to the carbonyl group. So this is the insertion process. Insertion. The 5-coordinated complex then reacts with the carbon monoxide. Then whatever the this compound is from, this is the pentacoordinated. The pentacoordinated compound react with the carbonyl, the carbon monoxide from the hexacoordinated compound, and after that release of acetyl iodide, giving the acetic acid product in the and HI. So this is the rhodium based 4 plus 2 cyclide addition reaction. So what happens in these cases? There is a 4 plus 2 type of reaction. So from this 6-member ring, what is the mechanism here? What happens? First, rhodium react with the pi bond and 2 plus 2 plus 1 type of cycloaddition happen. 2 plus 2 plus 1. So rhodium is the 1. This is so what happened in this case is Br rhodium. So this will like react here, this will here, and this will here. So 2 plus 1 cyclization reaction happen. This will give this rhodium attached product, Br rhodium, this one. Now insertion happen or oxidative addition we can say, or ring expansion. Ring expansion, oh sorry, there will be another one. Ring expansion or oxidative addition. Oxidative addition. So what happened? This rhodium is electropositive, this is electronegative. So this will go and this will react onto the rhodium center. So from 5 to 7 member ring it will form like this way. Rhodium, methyl, 1, 2, 3, 4, 5, 7. This will form. Now reactive elimination, giving the 4 plus 4 reactive elimination of the rhodium, giving the this will directly react with this one and this bond will break, giving the 4 plus 2 type of product. This bromo, this is the methyl and this product. So this is the 4 plus 2 type of product. Now I am going to discuss about the nickel based reagent. So 2 plus 2 type of cyclization reaction. So in presence of alkyne in and nickel trimerize, alkyne trimerize, trimerize to benzene. That is the 2 plus 2 cyclization reaction. So what is the mechanism? So first nickel coordinate with the alkyne, two molecule of alkyne, and this is the coordination happen, first coordination, and then 2 plus just like rhodium, 2 plus 1 type of oxidative cyclization happen, and from this nickel cyclopenta-annulated product. This is the cyclopenta annulation. Then one molecule of another alkyne it will coordinate, or there is a two possibility, one to migratory insertion or plus two type of reaction. So if it is one to migratory insertion, so this will go like this way and this will react onto the nickel center. So then from this 5 to 7 member, so 5 from 5 to 7 member nickel cycle, and then after reactive elimination, so this will like this will react and this will go reactive elimination giving this benzene ring. So this is one more possibility. So this is the nickel penta cyclopenta annulated product. So this can also react with the 4 plus 2 type of DHL atom. So this is can react cleaning the first one. This will first react, this will go and this will react. So giving the 4 plus 2 type of DHL atom. So after that this nickel bridge ring break, this will go, this will go, and giving this benzene ring. So this is the 2 plus 2 plus 2 cycloaddition reaction. So now I'm going to discuss about Adams reagent. This is the platinum oxide in presence of hydrogen. So this is basically hydrogenation reaction. Any kind, any alkene hydrogenated under cis orientation. So and if we use palladium carbon hydrogen, so this is also giving a hydrogenated product. So hydrogen react. So this hydrogen react under cis fashion. So this is the Adams reagent. So what happened in this case is this hydrogen react under cis orientation, cis fashion. This under any nickel hydrogen condition also you will get the hydrogenated product. Now I'm going to discuss about some problem which we have for today. So this is the first question is the silver acetate reaction onto the alkyne. So we all know alkyne has pi character, so it will react onto the silver. So the pi bond is activated, and then the nitrogen has lone pair, so it will react under 5 endo decyclized way. 5 endo decyclization. Now what to form? So this will give methyl hydrogen positive ethyl silver, and there will be one methyl group. So now deprotonation happen to neutralize the system. So this will go. So this will first form. Next what happen? Next the nitrogen of load pair react under, so in presence of H plus, so it will react with the H plus. It will give it will give this one proton silver. Now this iminium will form. So after that what happened? There is one proton. So beta hydride elimination happened. So this will beta hydride elimination. Beta hydride elimination. So beta hydride elimination giving this one, right? Now to stabilize the system, the deprotonation and aromatization happens. So this will go like this way, this will go like this way, and utilize this iminium. And from this spiral ring. So ethyl, this spiral ring will come. So what is the right answer? Option C is the right answer. Next is also silver. So here nitrogen is the nucleophile. What happened is there. So in spite of alkyne, alkene can also activated by silver. This is the alkene moiety. Alkene. So both alkene and alene can be activated by silver. So alkyne is this one, al alkene is this one, and alene is this one. Can be activated by silver. So what happened in this case? So first coordination with the pi bond of the silver. Then there is a two possibility. This can react either this side or either this side. So 5 exodic and 6 endodic Both are possible. 5-exodic or 6-endodic. So if it is 6-endodic, so this is the product. If it is 5-exodic, then this is the product. So which will come? So that depends on the substitution. These two substitution. This is the methyl. So if it is methyl in the both side or this is sterically hindered, for that sterically hindered, 6 endodic cyclization happen. If it is not sterically hindered, then 5-exodic cyclization happen. That also depends on the carbocation stability. So if it is reactant here, then that is the tertiary carbocation. So this is a tertiary carbocation. So then this O minus react on the dimethyl center. So this two methyl group decide which will form. So if there is a only one methyl less steric indent compound, so then 5-exo compound will the major product. So the 6-one will also form, but 5 is the major product. If it is substituted or sterically hindered or just like 2-methyl, then 6 is the major product. That depends on the carbocation stability. So now what happens? So here both in these cases both methyl are substituted. So this is go via 6-endodic. Sorry, it is not erasing. Some like this way. So after that, proto demethylation happen. Proto demethylation. So this is the partially positive. This is partially negative. So it will react with the proton and liberate this silver and generate this product. So this is the right product. So the right answer is the this one. This is a lactone. So this is lactone basically. So in these cases, the stability depends on these two methyl group. If it is sterically hindered, then 6-one form. If it is sterically less hindered, then 5-one is formed. So now is this one. This is a 4+2 type of cyclization reaction in presence of silver. What happened in these cases? So this is the lone pair. First activation of this imine by silver, and then so if we write properly, so I'm writing here benzyl. So this oxygen lone pair will go like this way. It will react and it will then stabilize here. So this is the 4+2 basically 4+2 cyclization reaction. Benzyl 0.0 TMS positive. This one OME pH. Right. Now what happened? So now this will neutralize giving this one NPH benzyl or okay. um, Followed by this nitrogen has lone pair, right? So or okay, right. 1 second. Keep it right this way. OTMS, yes, IME3. So this is the TMS, right? Okay. Then what happened? The silver hull also iodide or whichever the counter anion that will react onto the Silyl center. So this will go, and this liberate the OMe. So minus methanol and minus SiMe3I that generate this product. This one. So the right answer will be this one, last one. So first 4 plus 2 types of activation of the imine by silver, 4 plus 2 reaction. So this nitrogen react here, this will go and this will react onto the imine center. Followed by the deprotection of the Silyl group by the counter anion which are there. So this will react, this will go and liberate the methanol from this ketone. So enone basically. So this enone will form. So option 4. The next question also silver acetate. First activation, this alkyne activation of the alkyne alkane. Then what happened? Their debut is the base. The debut is the base. So the base abstract the alcohol proton from this negatively charged compound. So pH CH3 O minus, and that is activated by silver. Now the system has carbon dioxide. C double bond to now this load negative charge react onto the carbonyl from this negative that will react here under 6 endodecyclase pathway. 6 endodeg. There is a two possibility. It can react under 6-endodic or it can react under 5-exodic. So if it is react with the 6-endodic, what will form? It will form this one. This carbonate will form H CH silver. So this carbonate will form. If it is react with the 5-exodic manner, so then which carbonate will go? Carbonate. This is a carbonate CO3 minus carbonate. Here what happened? HCH3 silver. This is the 5-exodic cyclization. This is the 6-endodic cyclization. So after protodemetallation, this will give this one PHC3 and this will give a 6-member product CH3, this one. So depends on the thermodynamic stability. We can say that the 5-1 is the more stable one. So this is the exocyclic exocyclic double one are there. So this is the more stable, depends on the thermodynamic stability. So we can say this is the right product. So depends on the thermodynamic stability. 6 also possible that this product is also possible, but according to thermodynamic stability, this 5 is the major product. Now the rhodium based question are there. So what happened in these cases? So just like that, rhodium react with this 5 bond via 2 plus 2 plus 1 cyclized pathway, 2 plus 2 plus 1. So if rhodium are there, this will go, this will go, this will go. So 2 plus 2 plus 1 pathway will generate EMS, rhodium, this one. Now 1 2 instruction happen, 1 2 instruction. So this is partially positive, this is negative. This will go and this will insert onto the rhodium. So 5 to 7 ring expansion happen. TMS, rhodium, CH2, double one, methyl. Oh, there will be one double one from the alkyne, methyl. Now, reactive elimination. So this will react, this will reductive elimination, giving this methyl double bond TMS. So this is the right answer. So here, what happens? This or this. Now, in these cases, this is Adam's reagent. So hydrogenation possible. So hydrogenation under exo or endo. So this is the double one. So ketone will be hydrogenated. So this go like this way. So there is a two possibility. Does alcohol go on to the axial orientation or equatorial orientation? So if this is the methyl, so if it is this hydrogen will come from the axial position or from the upside. So there is a steric hindrance possible. But if it will come on the downside or the beta or the equatorial orientation, no steric hindrance. This is steric hindrance. There is no steric hindrance. So that's why it come from the equatorial orientation. So if it is come from the equatorial orientation, this alcohol go to the axial. So this coming from the equatorial, then alcohol go to the axial. This will be the major product, I guess. So this is the major product. So the axial product. So this one to avoid steric hindrance. So here no steric hindrance. So if hydrogen 1 3 steric 1 3 diaxial interaction, one to avoid 1 3 diaxial interaction. Now the seven is the Monsanto process. For Monsanto process, which statement is correct? The catalytically active species is the anion cis rhodium CO2. Yes, this is right. Diiodorhodium dicarbonyl will come first. This one. Then the first organometallic is the oxidative addition of the methyl iodide to the yes. Then in this cases methyl iodide insert. So methyl iodide oxidative addition happen. Carbonyl, carbonyl. Then from the hexacoordinated CH3 RH CO2 I3 compound. Okay, right. Next, the anion rapidly transform via the migration of a methyl group to the adjacent carbonyl ligand according the intercoordinated acetyl complex. Yes, this is also right. So this insertion happen from this pentacoordinated compound. I CO CH3 CO I I I. This is a pentacoordinated compound will form after the 5 coordination complex then it reacts with carbon dioxide to form the 6 coordinate dicarbonyl complex which undergo reactive elimination to release acetal. This is also right. After that carbon monoxide will react and form the hexacoordinated compound C3CO I I I CO. So CO carbon monoxide will react and form this hexacoordinated compound. Then reductive elimination of this methyl iodide, sorry, uh, acetyl iodide happen. So reductive elimination giving this CH3COI. This is the, so all of the above is the right. This is also right. Haplotype species of cis RHCOI2 will form. Then methyl iodide insertion from the hexacoordinated CH3RHCO2 I3. This is also right. Then anion rapidly transformed by a migration of a methyl group to an adjacent carbonyl center, avoiding the pentacoordinated acetyl complex RH3 CH3CORHCOI3. This is also right. This 5-coordinated complex then reacts with carbon monoxide to form the 6-coordinated dicarbonyl complex, which undergo reductive elimination to release acetyl iodide. So this is all of the above is the right answer. So this is the olefin process. To cell higher olefin process consists of three steps. So the order of the system: metathesis, oligomerization of ethylene, isomerization of C4C10 and greater than C2H2. So first, what happened in this cases? Oligomerization of the ethylene happen. So first ethylene molecule oligomerize, and then isomerization of the C4 to C10 compound happen, and then metathesis happen. So in this case, this is the 2, 3, 1 is the sequence. The next one is the nickel. What happen in these cases? First, nickel react with the alkyl, and this is the uh, uh, imine. So it will form 2 plus 2 plus 1 cycle addition product plus 2 plus 1 nickel. So this will go like this way, this will go like this way, and this will go like this way. So 2 plus 2 plus 1. 2 plus 2 plus 1. pH double 1. pH. This is pH. Nitrogen SO2P, SO2pH, nickel. Ln. I'm writing the quad cyclooctadiene as Ln. This will first form. Next, what happened? Next, one equivalent of alkyne is further here. Okay, this will go like this. This will double bond. Okay, this will be the single bond, right? So if it is like react with this way, then that will be the single bond. Okay. And one molecule of phenyl further insert. So one two insertion happen. So nickel is electropositive. This is electronegative. So this react this way, and this will react onto the nickel center. Then it will form pH, pH, nickel, Ln, nitrogen, SO2 pH, bond. Then reductive elimination. So in reductive elimination, this is electropositive, this is electronegative. So this will react under reductive elimination, giving 1, 2, 3, 4, 5, 6 member ring. 1, 2, 3, 4, 5, 6 6 member product. pH, 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 pH. This pH is this one pH. So the right answer will be this one. So I think this is clear. So first 2 plus 2 plus 1 cycloaddition reaction in presence of nickel, giving this pentacoordinated nickel compound. After that, insertion of this alkyne, 1 2 insertion giving this hexacyclic compound. This is a pentacyclic compound, pentacyclic nickel compound, then hexacyclic nickel compound. After that, reductive elimination of the heptacyclic nickel compound, giving this hexacyclic product. This one. Now is this one, Graph's catalysis. Okay, so this the ruthenium graphs. So this will react like this way, giving this 4 member 2 plus 2 cycloaddition. We all know in the Graph's metathesis reaction. First undergo 2 plus 2 cycloaddition reaction. Ruthenium pH. Further what happen? This will retro 2 plus 2 happen. Or retro 2 plus 2 cycloaddition reaction giving this product. CH2 double one RU. Now this one. Now further 2 plus 2 cycloaddition. This is the retro 2 plus 2 retro 2 plus 2. This is the 2 plus 2. 2 plus 2. This react here and this will react here. This will give 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 member ring. Here upside. N double bond to 6 member ring will form. this one. So this is the first product, which is A. Now what happened? So they use lithium aluminum hydride, right? So lithium aluminum hydride is the reducing agent. So it reduces ketone aldehyde, ester amide. So this is the amide group. So in presence of lithium aluminum hydride, this amide is reduced to amine. Amide to amine conversion will happen. So this will come. What is the mechanism here? The first ketone react with the aluminum center and this imine nitrogen, especially this one from this aluminum hydride. Now one molecule of hydride further react and liberate this one, this giving this iminium. Further, one molecule of hydride react onto the iminium and neutralize this to form amine. So this is the right answer. So what is the right answer? This one, option C. First, in presence of that, it will form the six-member ring, and in presence of lithium aluminum hydride, this amide reduced to amine. So these all are the 10 questions which we have today. So if we summarize today's class, so first I have discussed about the activation of the alkyne by silver-based reagents. So in the previous class, I have discussed the gold-based reagent. Here I have discussed the silver-based reagent. So terminal alkyne or substituted alkyne are activated by the silver. The pi bond of the silver react onto the pi bond of the alkyne react onto the silver center. So from this and activate this via this way or this way, and further reaction happens. So in presence of nucleophile or electrophile, it will react onto the alkyne center and form substituted product. So if there is an intramolecular nucleophile are there, so this is the intramolecular nucleophile. Intramolecular nucleophile or amine are there, so this will can react onto that alkyne. So after the activation, so that give the further product. So in these cases, I have discussed about the hydroamination product. So the hydrogen, this hydrogen and amine react onto the alkyne. So this is called hydroaminator. Next, I have discussed the 4 plus 2 cycloaddition reaction by silver based reagent. So just like silver activate the alkyne and further substitute this double one react and forming the 4 plus 2 attack product. So next I have discussed about the Monsanto process. So in these cases, acetic acid formed from the methanol via catalytic amount of rhodium carbonyl diiodide. So in that cases, first methyl iodide oxidative addition happen from the hexacycle hexacoordinated rhodium, followed by methyl migration and methyl insertion, giving the acetyl pentacoordinated rhodium and further carbonyl addition and subsequent acetyl iodide reductive elimination, followed by oxidation, giving this acetic acid as a product. So next I have discussed about the rhodium catalyzed 4 plus 2 cyclized product. So in these cases, Rhodium react with the alkyne first and then undergo 2 plus 2 plus 1 cycloaddition product followed by 1 2 alkene addition and subsequent rhodium reactive elimination giving the rhod 4 plus 2 annulated product. Next, I have discussed about 2 plus 2 plus 2 cycloaddition product by nickel. So in this case, the molecule of alkyne trimerized to form benzene ring. So via first nickel react with the two alkyne and undergo 2 plus 2 plus 1 oxidative cyclization and form the nickel coordinated cyclopentadiene ring, and then further one molecule of alkyne react or one to migratory pathway giving the benzene ring or via 4 plus 2 decellular reaction and retro decellular reaction giving the benzene ring. So and then I have discussed about the Adams reagent with the platinum oxide under hydrogen undergo hydrogenation reaction via cis orientation. These are the question. So yes, if you have any question you can ask. Otherwise, I'll close the session. Okay, then.